Hello, dear young minds. Welcome to PhysicsPoint. Today, we are going to start your ninth standard physics syllabus. The first chapter is going to be motion. All right, we are going to do in detail analysis of this chapter. So, take out your pen and notebook and get ready for this beautiful journey. All right, now before getting into the motion chapter, let us understand few words here. Let us try to understand this word that is called kinematics. All right. So, what is the meaning of kinematics? Kine means it is motion. The meaning of kine is motion, and mathematics means it is just as usual mathematics. Okay. So, whatever mathematics of motion is there, that's what we are going to study in your ninth standard. What do you mean by the mathematics of motion? I mean, you must be thinking how much distance is covered. All right. And what is the speed? All right, there is one more word called what is the displacement. What is the displacement? And you will get some word like what is the velocity. What is the velocity? How much is the acceleration? What is the value of acceleration? Then how much force is there? I mean, that will how much force is there, that will come in laws of motion. That's a different issue. Then Newton's first law, then Newton's second law of motion. Then we'll study about Newton's third law of motion. Then we'll talk about so many things like inertia. Then we'll talk about the word called momentum. All right. Then law of conservation of momentum. Law of conservation of momentum. I don't want to confuse you at the initial stage only. These are the things which we are going to study. All right. Now, on the broader case, let me give you some idea. I mean, I have drawn some pictures here. All right. Just to give you some idea about what the motion and all is about. I mean, if you come to the definition of motion, dear children, if you come to the definition of motion, what do you mean by motion? It's quite a simple definition. I mean, the definition goes like this: if a body, if a body changes its position, changes its position with respect to, with respect to its surroundings, with respect to its surroundings, with respect to its surroundings, then the body is, then the body is said to be in, said to be in motion. All right, please observe this definition. What does it says? If a body changes its position with respect to its surroundings, then the body is said to be in motion. Now look at this, have a look at this diagram. This person is going forward, okay, in the car he is driving. I mean, he feels like this tree is going backward, right? But it is not going. This tree is at rest only, but he feels by sitting inside the car, if he is moving forward means he feels this tree is moving backward, right? He is feeling that, he feels the tree is moving backward. All right, it is moving backward, he feels that, but it is at rest. All right, so whatever he is sitting inside the car, no, so he is sitting inside the car. So sitting inside the car is known as frame of reference. What is this? This is known as frame of reference. Now, what is this frame of reference? Frame of reference means a frame of reference is nothing but inside the car. He is sitting inside the car. Now, that is only known as frame of reference. For example, you are inside the lift. Okay, so then lift becomes what? Your frame of reference. Are you getting my point? Wherever you are there, that becomes your frame of reference. All right, let me give you one more example here. For example, let me put a smile on this person's face. All right, I think it hasn't become smile, and one more smile on this person's face. This is person A and this is person B. Now both are sitting inside the car, no? Now for example, any tree is side by. Okay, so this person A, when this person sees this tree when they are moving forward. For example, they are moving forward, they feel like the tree is moving backward. All right, but the same person, when this person A sees the person B, the person A will feel that the person B is at rest. Why they feel, why the person A is feeling the person B is at rest? Because both are having same frame of reference. Here also frame of reference is same, here also frame of reference is same. Both are having the frame of reference inside the car. They are sitting inside the car, no? So both are having same frame of reference. That's why they feel like they are at rest. All right, same is the case with person B. If person B sees person A, then the person B will be feeling that the person A is at rest. But person A is moving forward, person B is also moving forward. All right, as frame of reference is same, they appear to be at rest to each other. But any person standing outside, for example, any person is standing outside like this, if he sees A as well as B, what this person will feel? This person will feel that both A and B are moving forward. And if both A and B sees this person C, then they feel that this person C is moving backward. If he's, even though he is at rest, they feel that this person is moving backward. Right? Now here the tree was at rest, no? But this person was feeling, he was moving forward, he was feeling that this tree was moving backward, even though it was at rest. All right, so motion, it's all about your perception. All right, what kind of perception you have, what kind of frame of reference you have. Okay, based upon that the motion will be decided. All right, all right, I hope you are understanding. Both of these will look at rest to each other because their frame of reference is same. All right, fine. I think you got to know the idea about motion. What is motion? Motion is nothing but if a body changes its position with respect to its surroundings, then the body is said to be in motion. All right, I have given you some examples here. You can have so many examples in your textbook also. There are so many given. All right, now coming to the next thing, what are the different types of motion? What are the different types of motion? There are so many types of motion, but broadly they are divided into two types. I'll tell you. Look at this old lady. All right, this old lady, do you think her speed keeps on changing every now and then? No, right? He's holding a stick, walking stick. Her speed will be always same, no? For example, if you allowed her to walk for 10 minutes, in starting 10 minutes, maybe she went for example, let us take a 0.5 kilometer. All right, and in another next 10 minutes you took another 10 minutes. In the next 10 minutes again you saw, again she traveled 0.5 kilometer only, because her speed is same. She walks at the same pace. She is not in hurry, she is neither too slow nor too fast. Okay, next another 10 minutes you have given her. Again she must have traveled 0.5 kilometer. I am just giving an example. Okay, so in every 10 minutes she is traveling how much distance? She is traveling a distance of 0.5, 0.5, 0.5. Whenever you give her 10 minutes, she will be traveling 0.5 kilometer. This is a classic example. Okay, so this kind of motion is called as what? A uniform motion. What is this motion? Uniform motion. Try to understand uniform. Uniformly she is traveling. Uniform motion as in, for example, you have taken this time interval. For example, I have taken this example of Dhoni also here. For example, if you see this Dhoni, when the ball is very near and he wants to take a run, means he will run very fast, right? This person will be going very fast. Dhoni will be going very fast to take that run. If the ball is very far away, and he may go slow also. All right, now his speed is not constant. He is traveling with different speeds according to the situation. Now this kind of motion, whatever it is there, no, this kind of motion is known as non-uniform motion. Non-uniform motion, because to cover the distance between wickets, sometimes he is taking maybe 20 seconds, and sometimes he is taking only 10 seconds. All right, but here this lady is taking the same time to cover same distance. So that's why this kind of motion is known as what? Uniform motion. There are two types of motion. One is uniform motion, another is non-uniform motion. Let me give you the definition of uniform motion. Uniform motion means if a body covers equal distances, if a body covers equal distances in equal intervals of time, if a body covers equal distances in equal intervals of time, then it is called uniform motion. Please make notes, start to make notes. Okay, let me give you the tabular representation. For example, you are taking some time interval here. Okay, time interval, and you are taking some distance traveled here. Okay, now you have checked that for example, starting 0 to 5 seconds, you have checked 0 to 5 seconds, you have checked that the distance traveled is 10 meter. Again, from 5 to 10 seconds, you have checked the distance traveled is 20 meter. 5 to 10 seconds as in continuously. After 5 seconds also you started to check 5 to 10 seconds. 20 meter as in, you can take this as 10 meter only, no issues. 10 meter, in starting 5 seconds 10 meter, in the next 5 seconds again 10 meter, in the next 5 seconds again if you check it is again 10 meter. Okay, 10 to 15 it is. Okay, 10 to 15, again 15 to 20 you checked, again 10 meter. In every interval of time, in every interval of 5 seconds, 5 seconds, 5 seconds and 5 seconds, the distance traveled by the body is 10 meter, 10 meter, 10 meter, 10 meter. That's why I wrote the definition. If a body covers equal distances in equal intervals of time, then it's called uniform motion. All right, now this old lady is in uniform motion according to the situation whatever I have explained. In starting 0 to 10 minutes she traveled 0.5 kilometer, then again 10 to 20, 10 to 20 means again 10 minutes only, again 0.5 kilometer, then 20 to 30 means again 10 minutes only, 0.5 kilometer. That's why she is said to be in uniform motion. All right, now let me give you the example of non-uniform motion and definition of non-uniform motion. All right, so what is the meaning of non-uniform motion? I will give you. All right, now look at this. This car must be traveling with some speed. All right, he look at this car. He's in urgency. He's going very fast. Okay, speed is quite high. All right, and he may be not into a rush, so speed is only this much. Okay, 3 arrow marks I have shown means more speed, 2 arrow mark means less speed, and this person may be going with speed with only 1 arrow mark, low speed. See, look at this. These people are covering different distances in different intervals of time and all. That kind of motion is known as what? Non-uniform motion. Before giving you the definition, let me give you the tabular representation. For example, I will take time interval here, and I will take distance. Okay, so for example, I have taken time interval 0 to 10 seconds, and 10 to 20 seconds, and 20 to 30 seconds, and 30 to 40 seconds. In the starting 10 seconds I have observed, the body covered 10 meter. In next 10 seconds I have observed the body covered 12 meter. In the next 10 seconds I have observed the body covered only 5 meter. In the next 10 seconds I observed it covered 100 meter. Now look at this distribution. Now what is happening here? The time intervals are equal, 10 second, 10 second, 10 second and 10 second. In equal intervals of time, the body is covering unequal distances. This is called as what? This is an example for what? Non-uniform motion only. All right, let me give you one more example. Here is the time interval. All right, time interval, and let me take the distance also. So here the time intervals are like 0 to 10, then 10 to 15, then 15 to 45, then afterwards 45 to 60. And distance we have calculated, it is like 10 meter, 10 meter, 10 meter and 10 meter. Now look at this distribution. What is this distribution? Here the distance traveled is constant, but time interval here it is 10 seconds, and here it is 5 seconds, and here it is 30 seconds, here it is 15 seconds. All right, if the body is covering equal distances in unequal intervals of time, okay, then also that is an example for what? Non-uniform motion. So that's why we can have two definitions together. What is that? If the body is covering unequal distances in equal intervals of time, or it is covering equal distances in unequal intervals of time, then both are the examples or cases for non-uniform motion. I think we should be able to write the definition now. What is non-uniform motion? If a body covers unequal distances in equal intervals of time, or equal distances unequal distances in equal intervals of time, or equal distances in unequal intervals of time. Okay, unequal intervals of time, then it is called non-uniform motion. I will be using these shortcuts. You can also use them, otherwise you have to write it full definition so that you get feel of it. All right, so I hope everybody is understanding what I'm trying to say. I started with kinematics, no? So I will bring forward this. What is this kinematics? There are so many other words also. Okay, I will give you mechanics, dynamics, statics, all those words I will give you. All right, then we have started to know about the meaning of motion. Then after that we have seen so many examples, and we got to one word, frame of reference. What do you mean by frame of reference? The place you are from where you are observing the motion. Frame of reference means it's the place from where you are observing the motion. From where you are seeing the motion, whether you are seeing it from inside the car or outside the car. When you see from inside the car moving forward, then you feel that the tree is going backward. And if you are standing outside and if you are rest, the tree will you feel that the tree is at rest only. All right, and you are inside the car. If you see this person, you will feel that this person is at rest. And you are here, and if you see this person, you will feel that this person is moving forward with some speed. All right, it's all about your perception, how you are going to perceive that. All right, here the frame of reference is inside the car, here frame of reference is outside the car. All right, I have given you the example of uniform motion, then example for non-uniform motion. Okay, and I have given tabular representation also. All right, so I was talking about that word called kinematics. No, there is a big branch of physics which is called as mechanics. Okay, mechanics means something related to motion. That's it. Mechanics, for time being, you just get to know about that. Mechanics means something related to motion or machines, movement of machines and all right, so this mechanics is divided into two parts. Okay, the first part is called as dynamics. Okay, dynamics, and next one is called as statics. Dynamics and statics. Okay, statics we won't study much. Okay, statics we are not into statics and all. So this dynamics is again divided into two parts. One is kinetics, and next one is kinematics. In the motion chapter, what we are studying about kinematics. Now you must be thinking, sir, what are these words? So what is this mechanics? What is dynamics? What is kinetics, kinematics, statics? Now you get to know about these words. So these entire things will be discussed in 11th class. I can discuss now also, but in your NCERT textbook, these words are not mentioned. Mechanics, dynamics, statics, kinetics, kinematics are not mentioned. So on your own, you get to know about that. And if you want to, listen to that video of mechanics, what is the difference between this dynamics, statics, kinetics, kinematics, then please comment below. All right, then I'll be making a video about that. All right, this series of videos are going to be quite useful for you. Like this video, dear young minds, because your liking will push these videos into the top of the YouTube so that it reaches maximum number of people. And share this good work with all your friends from other schools also. all right, from your school also. And don't forget to comment on whatever you want to listen from us. You have watched this video for nearly about 20 minutes. What are your feelings? I mean, how you are feeling about this, and this series should continue or not? What you want to listen from us, whether you want to know about these mechanics, dynamics, statics, kinetics and kinematics in detail or not? What you want to listen from us, that's what you need to comment. And don't forget to subscribe to the channel, because it is your subscription which will give us a lot of motivation to shoot much more videos like this. All right, dear young minds, thank you very much. Have a good day and bye bye. I will see you in the next video with the Motion 2. Thank you very much.